Thank you for joining us for today's webinar, Waterproofing Decks and Balconies. We have some brief housekeeping before we start. Your phones are on mute. If you have any questions, please type them into the Q&A box in the corner of your screen, and we'll answer them at the end of today's session, time permitting, or via an email after. And you can always send questions to mapeidigital@mapei.com. Now I'd like to introduce today's speaker, John Lucas. John is the Business Development Leader, Building Envelope Systems Waterproofing for MAPEI Corporation. He has over 25 years experience within the construction industry in the fields of waterproofing, manufacturing, chemical coatings, architectural coatings, and high-performance coatings, as well as in new product development and technical support. While at MAPEI, John has trained thousands of American, Canadian, and international end users, inspectors, and consultants on waterproofing, insulation, and air and vapor barrier membrane installation methods. He's also developed installation instructions and technical documents for both existing and newly developed products. He's advised design professionals in project-specific membrane applications, and he's created CAD drawings to reflect those specific conditions. John has a BBA in accounting and BAs in biology and chemistry from Baylor University in Waco and an MBA from Tarleton State University in Stephenville, Texas. With that, I welcome him to the microphone. John, the floor is yours.
Thank you very much. Thanks so much for the introduction. Kind of embarrasses me sometimes when people talk about me. Hello. John Lucas here, deck and balcony waterproofing. Before we get kind of into this, I just wanted to dial in the scope a little bit of this presentation. For those folks who are familiar with MAPEI manufactures a wide, some would say huge, variety of products that can be used on decks and balconies for new construction, rehabilitation, and repair of decks and balconies. This presentation will cover only the primary waterproofing of decks and balconies over occupied space, primarily in new construction and rehabilitation. As per the invite, this is the outline or some of the topics for today's presentation. We'd like to take a second to mention that this particular presentation, because of the proprietary nature, primarily the last portion of this, and has not been submitted to the AIA for continuing education credits. Before we kind of begin on this, I wanted to let's walk through some definitions, if you will. Start from a foundation of knowledge and build from there. So let's talk about a deck. What's a deck? You know, decks are on ships, decks are on boats. We're not going to talk about them here. There are decks on ships and boats, but we're not going to talk about them in this presentation. Deck as in punching someone very hard, usually in the face. No, we're not going to talk about that here either. But what we are going to talk about are the structural horizontal elements, primarily with concrete. They are exposed to the environment. They are over occupied space, whether a human is the occupier, the human is the user, or some other type of vehicle or instrument that a human uses. The decks that we also were talking about typically are rooftop type decks. They're all roofs. At the end of the day, anything over an occupied space is a roof. Rooftop decks and podium decks. Rooftop decks are pretty self-evident. They're on the very top of the building. We're just trying to expand the use of the building by putting a deck up there. Podium decks need a little bit more explanation because they can be above grade and below grade. The above grade, basically what it is a structural element that connects buildings. Typically in multifamily, lovingly called mixed use developments. They have pools, patios, green spaces, etc. to add some folks call them amenity decks, also another name for them. Plaza decks is another name as well. The other is called podium deck, that is below grade, is if you have an above grade building, multi-story building in a downtown location, and the above grade structure is smaller than the actual building footprint. And so if you're on the street level walking up to that above grade structure, you've been on top of the building and you just didn't know it. As every step you get closer and closer to the door, you're actually on top of it, what's called a podium deck. So a little bit there on the definition side. So we've got two subjects, decks and balcony. So balcony. Balconies made of wood decking, wood posts, and an awesome place for me to get my summer tan in. No, we're not talking about those either. And for those who use the Urban Dictionary, looking up balcony, please don't do that. We're definitely not talking about that. But what we are talking about are exterior floor slab extensions from the wall or from the building footprint. They are supported by the structure of the building, not, some folks call it cantilevering out. They can have structures, but all that load is transferred to the structure. There aren't any support posts outside of the building envelope supporting that structure. They can also be separate concrete pours in a plywood pan, if you will, pouring concrete on top of the plywood, and will waterproof the plywood with the support timbers typically connected to the structure. So all that load is transferred, again, back to the structure. That's what we're talking about today. So what does it look like? Thank you for asking, I appreciate it. And here you go. So if you look at this small little picture, I apologize for the size of the picture. I just have other pictures to cram into this slide. If you look at this picture, this has both elements of balconies and elements of decks. The deck is the lower left. It has a paver and a green space. There's a patio underneath those balconies. And then you can see the balconies. If you follow the floor lines, if you look at the second story one, you'll see the floor line, and it lines up perfectly with the balcony. So that's what I mean by floor slab extension. Another one, again, a podium deck in the foreground, a plaza deck, some would say. There's a little planter feature there in front. And then in the background, if you look at the building in the background, it's all part of this particular larger building. If you look at the building in the background, you see several balconies, as well as in the center, and then up on the right, you'll see another balcony up there as well. And you can see that they're over occupied space. And this is what we're talking about. This is a podium deck taking advantage of a water feature. And so you can walk out on here, but the building's right next is to the right of the photograph. And these are support elements for pavers. Here's a rooftop where they've used the tile and mortar and grout to increase the living space, the usability space of this particular building. Balconies, what do they look like? That's what they look like. That's one for a condo and one for a multifamily apartment complex. One would look at it and say, well, geez, John, there's a porch. If you look at the photo on the right, gee, there's a porch there. Well, there's a door and a human uses it by, that's basically over occupied space. Just because there's air on 3 sides of the balcony doesn't mean that you don't waterproof it, because it's attached to the structure. So why again are we waterproofing? Well, mandated by the code, whether it be the International Building Code, state, local. There are some federal ones with the U.S. Army Corps of Engineers. While I am talking about state mandated code, let me read you the California Civil Code 5551 Alpha 2 exterior elevated element, EEE, load bearing component together with their associated waterproofing system. Some more definitions. It extends beyond the building's exterior walls, designed for human use, has a walking surface more than 6 feet above the ground level, Load-bearing components can be also made of wood or wood-based products. They include balconies, decks, porches, stairways, walkways, and entry structures. Associated waterproofing systems include flashings, membrane sealant. God. I got really bored at about the third 5. I don't know about you. That is a code. I'm not a lawyer, and I do not even pretend to play one on TV. But this is mandated by code. That's one really good reason why we're going to waterproof a balcony and waterproof a deck. One of the other one is a high cost of failure. Water intrusion can cause wood rot. It can also deteriorate the concrete. If we're rotting wood and deteriorating concrete, we're endangering lives and property. Let's say a balcony falls on a car. That would be the property, or damaging the value of the whole entire structure. Remediation costs. If it costs you $1 million to put it together, it's going to cost you $10 million to fix it. The average repair cost on a podium or plaza deck is $70 to $120 a square foot, depending on the complexity and use of that deck. Other costs, the topping slabs or the paver and pedestal systems, the mortar adhered tile, any type of green space, overburden, water features, these type of, they have a shorter life cycle because the waterproofing, if we haven't waterproofed it, then that compromises their expected life. 2016 study, they studied 239 major deck failures and found out that 4,600 folks, people, humans, went to the emergency room. I guess the caveat is, hey, most of them ended just in injury, not death. The fact that they mentioned death is not a good thing. And another another study released in 2009, a little bit more, a little broader scope, obviously, but it also brings that, okay, that's 4,600 emergency room visits. So what's the threshold of calling a ambulance versus not? Bumps, bruises, right? So there's 33,000 injuries associated to these type of failures in that time period. So that's a 5-year time period. The previous study was over a 15-year time period. So what exactly does a balcony failure look like? As you can see, that this is a floor slab extension. Look at the damage to the left of the picture. It's just broke. Unfortunately, this one is a very famous one. It found its way to the USA Today, which is a nationwide publication in the States. There were 13 college students they all happened to be from Ireland. And no, this didn't happen in March, it happened in June. One would think Ireland in March would be a way to gather 13 people on that small balcony. Unfortunately, 6 of those folks who were on that balcony did not make it. They died. And the other 7 were admitted to the hospital. You can see that this is a wood structure or wooden support structure connected to the load is being transferred, unfortunately. And you see the black thing, the curtain there, that's the membrane. And unfortunately, these things happen. And this is unfortunately one where back in 2015 is one where some folks didn't make it. This is another one happened in it seems so California and New York. A lot of people there, so there's a lot of apartment complexes. Here's another one where the balcony collapsed onto the net floor below. There were some injuries on this, but again, 7 stories up. If you were to fall out from 7 stories, I'm not so sure you'd make it. I think at worst case scenario, you're looking at death. Best case scenario, you're breaking something. This is not a balcony failure. This is just plain stupid. But these are some seniors, apparently high school seniors from 2015, because I'm reading this, and they were having some sort of fun times. Looks as though we have some 18-year-olds having a good time here, and it looks as though they have some adult beverages as well. And that may be the reason why that they're not using their education very well and occupying this structure. This is not a deck, not a balcony. This is basically a deck as far as it's supported by those, not supported by the building, but only most of the load is being transferred to these support posts below. A deck, you don't know what a deck failure is until you see a wet spot on top of the deck, area that doesn't drain. Maybe the green space is having some mud issues. We're having a leaking planter. We're having a trip hazard created by the movement, excessive movement below on the paver and pedestal system, for instance, or a topping slab is cracked. We've had just beyond some of the features, the overburdens, we'll lovingly call them, have started to move around a little bit too much. So instead of fixing it, some folks will put on the upper left, we'll put a piece of a metal pan and collect the water and move it around. If you don't put a metal pan there, the one on the upper right, you get those. Those are lovingly called stalactites. And you may have a stalagmite below, just like a cave. But again, is indication that there's a leak up top. We're leaching minerals out of the topping slab or the structural slab. I mean, and it's coming down below in the space below. And the one in the lower left, we have a tenant here with a wet carpet on the other side of that window wall. And finally, they got tired of replacing the carpet, calling cleaning crews in, and they just had this moldy, mildewy smell in this room, in this area behind the window wall. Contacted the owner of the building. The owner of the building calls up and hires a contractor. They saw cut into the deck, and lo and behold, there's ponding water. And the ponding water is going right into the building. So that's another look at a deck failure. Again, this doesn't look cheap. This is expensive. A lot of disruption happens. So that's why we should waterproof balconies and decks. So let's talk about some of the challenges. And then in the way we design this thing, so here's some challenges, then we're going to kind of cover some of the challenges up with some design considerations. So let's get going here. So there's a couple of common challenges that are out there. Damage, using the wrong products, planners of particular usually it's post-installed planners, and then overall lack of construction details. And there's a little bit of a conflict here between aesthetics and function. We'll talk a little bit about each one of these things, starting off with lack of construction details. Guess where decks and balconies leak? All these areas. Guess where we don't have construction details? All these areas. We have to handle all of these areas in order to have an effective way to counteract some of these are some of the challenges that need to be counteracted in the design process. And you can see the one picture with the fellow with the black membrane, that's a transition flashing from a concrete surface to a wall, and they has to be continuous. So that's what that affects do. Planners. Planners are green accents on the deck. You saw in that one picture, it can be something that looks like it's movable or running around. The big challenge here is where to waterproof it. Well, we'll just kind of create a bathtub inside the planner. Okay, that's great. You can also do it under the planner by, if the planner is designed, you can actually waterproof the entire structural deck and then insert your planner and then waterproof the walls. So the answer really is both. Also understanding too, some of the challenges are planter vegetation. So if we have a real small tree and then 15 years later, it's a huge tree, I'm not so sure that we designed for that. Location of drains. There should be a drain in the center of the planter, and all of the concrete, everything needs to slope to that drain so we can effectively remove the water. Some drains have what's called neck ups, where accesses, so they drain in two places, and then they have a very high point so they can maintain some water in the planter for the vegetation to live off of. Sometimes folks want to put some electricity, light these green features up. And so a lot of times it's a matter of when you put these electrical penetrations in, and is there adequate stub ups from the structural if you're bringing it in on the structure. The drain on the picture is on the left and the electrical is on the right. And the red line all the way through is the structural waterproofing, and then there's a little bit darker line on the inside of the planter, and then that would be your planter waterproofing. Use of improper materials. These are the three things that cause most of the problems is on decks. Most decks are designed with slope and delivered without slope. So we have this ponding water accumulation is called a pond on the deck. When we don't use the right materials that are designed for that, guess what happens? You get problems. Secondary waterproofing is not designed to protect the structure. It's a design issue. It's not designed for that. Moisture cured urethanes, while they do pretty well, they do good on vertical walls and areas that are dry and they cycle from dry to wet, or they're in really good slope and maintain that slope, they perform okay. But in areas where they don't and there's some ponding water, you get that. The picture is a reverted moisture cured urethane. What brings it together tears it apart. The little dimple board across the top, just so you know, is a drainage composite. Cold fluid applied rubberized asphalts. Rubberized asphalts are fantastic. Whenever you try and put them in water, they have to add a soap to it to get it to be miscible. And the problem is you're putting rubberized asphalt, it still has that soap with it, and then it becomes reverted as well, becomes soft and no longer functions. So cold fluid applied rubberized asphalts are typically only designed for vertical, not horizontal applications. So these are some other challenges some folks are, and you can imagine this is an expense. So these are all cheap. So let's talk about aesthetics. Picture from the very first slide, right? Looks cool, right? We got a water feature. We got all of this stuff behind them. You'll see it. I don't know, you won't see it, but behind the photographer, there's a pool. But all sorts of stuff that we want to put on top of this roof. A balcony and a deck. The roofs, because we're over occupied space. That's what you call that thing above your head, a roof. Unfortunately, we're putting all of this stuff, we're really making this very, very complicated. Now, the big, I can assure you that roofing has quite the number of details for installation, and there are quite the number of details for waterproofing. There are more for roofing without any overburden than there are in this picture for waterproofing. So we definitely want to make sure that we handle a lot of this stuff by making sure that we understand the impact of any of these things or all of these things on our system. This is all, by the way, lovingly called overburden. All of these things are overburden. So if you hear me say overburden, think of that stuff. Yes, you can put walkways and driveways on some of these podium decks. Absolutely. So let's talk about post-installation damage. Again, these are the challenges for decks and waterproofing, decks and balconies. Who did it? Well, we can all sit on a baseball diamond and point to first base, and the first baseman points to second baseman, and eventually come back to ourselves. Who did it generally is it's any number of folks on a project. I don't think it matters who did it, only to the general contractor, because that's who's going to pay for the repair. Excuse me. General rule of thumb: the more complex the overburden is, the more likely it's going to get damaged. It's actually adding more ingredients to the recipe, so to speak. How to resolve it? Every manufacturer has standard repair details. And they have to be followed closely to bring this waterproofing back to service, back to a waterproofing layer, instead of a destroyed or damaged a membrane. So that's how we take care of that. So those are your challenges. Okay, let's make sure we covering all these challenges in our design consideration. The first thing is, let's get to the top of the funnel and then we'll dial it down to decks. Kind of, you'll hear me, that's a very common theme for me. So let's, again, basic understanding of design considerations for any primary waterproofing is we got to talk. Communication, 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 water stops, communication. So we got to talk, pre-con. The documents have to talk. They have to be cross-referencing each other no matter where we are. And we always have to insist from the Division 3 trades, monolithic and smooth substrates. Water stops at every concrete pour and around penetrations. This is the suspenders to our primary waterproofing, water stops. Something very innocuous, very underrated, but it's a great thing to have. If you don't have them, you will be sorry. Manufacturing installation, this is kind of a standard, but it's again a communicating to the installer from the manufacturer. It's a communication piece. So let's dial it down. That's great for all primary. So what are some specific things at deck and balcony waterproofing? We got to understand the overall design requirements. That's great, John. I appreciate that, but I made these drawings and I appreciate that. But you need to go to the site and take a look at what your drawings have become. And if there are some drainage requirements, we have to have adequate drainage. So we're either going to drain it by using in-place, poured-in-place drains, or we're just going to slope everything to the edge. And they're fine. Or we can use a trench drain at key areas. There's all sorts of different ways but we must have adequate drainage. Construction method and some of the weather during construction, those things will affect scheduling, timing. Are we going to waterproof this deck in the wintertime? Are we going to waterproof it in the most rain season? Is it really hot and really humid? Or is it the other way around, high and dry? High altitude, dry conditions. I'm thinking Prescott, Arizona. I'm thinking Flagstaff, Arizona. It's plenty dry and plenty high. So we have to understand where we are too, the locations of everything. So substrate condition, how many types of substrates do we have on our project? Well, if we've got a podium deck with a balcony and the balcony's got plywood pans, so that's plywood. The other is structural concrete, that's concrete. What type of concrete is it? Lightweight? I don't know. Is it regular concrete? I don't know. Is it cast planks? I don't know that either. But we need to know this. If in some cases they'll put accelerators on top of the concrete to get it to cure faster, we need to know what those are. We lovingly call those contaminants. If we have a lot of traffic on there to move equipment, rebar, and the like around, if we have some petroleum or some hydraulic fluid contaminants as well on top of the surface, we need to know how to take those. Of course, we always want to make sure that the design team's intent is married with the owner's need. Got to have the details, especially that wall to other membrane. Transition from the deck or balcony waterproofing to the wall, and if there's any other type of membrane that we're going to come in contact with, we need to have details from the manufacturers. And the last is structural movement. These can be very, very large structures, and they can be very in a highly motile or a lot of movement. And so we have to understand what the effects of the movement are, and because they are going to affect a deck. And in large balconies, they can affect them as well. Dialing a little further down. So these are the things that we talked about a little earlier. We take care of these on the decks and balconies. Drainage, got to have adequate drainage. Got to avoid the ponding water. You saw the little photo of the ponding water. There has to be an overflow plan, especially for roof decks. And this can be scuppers, which are ports inside the parapet walls. They can be so what happens if the primary drains get blocked? What happens to that water? It accumulates. Where's it going to go? Let's hope it doesn't go in the building. But let's see if we can get it to flow outside the building and stay outside the building. slope. Some folks call it fall, so I put both words in here. Just wanted to make sure I'm clear on this. Positive slope to drain. Water's got to go from A to drain, area to drain. Would very much want to avoid a flat or zero slope deck or balcony. If it's a balcony, you always want the slope away from the building, slope away from the building. You don't want it sloping in the building. That's not a good thing. Most waterproofing membranes have what's called a 1/4 inch per foot. If you do the math on that, it turns out to be 2.096% slope. Most of them, that's suitable. What are you going to get though? What should you plan for? Well, you should plan for the flat or zero slope. I wouldn't use materials that don't give you performance at zero slope and ponding water conditions, because that's what you're going to get. You can specify and design everything you want to, but sometimes you get what you get. Most material suitability, making sure that that material is designed for zero slope and ponding water situations, as well as the atmospheric, and also designed for going underneath planters, underneath green materials or heavy pavers. Movement joints, seriously consider curbing those out of the wet zone. They are the biggest weakness of any type of waterproofing system because they're dynamic. In other words, they move, especially seismic ones. I would curb them up and get them out of the wet zone, get them out of the water. I think that the best waterproofing, the best movement joint is one that's dry. Making sure that the two manufacturers of the one joint manufacturer and the waterproofing company manufacturer, that they understand and know who each other are and have details. Testing. I could spend 6 hours on testing. I'm not going to do that. But there are two options. The flood test is in everybody's data page. 24 hours, 2 inches of headwater minimum. If a consultant is commissioned on the deck for a waterproofing consultant, they will insist on 72 hours. It takes a while for a small defect to daylight source of a leak. The more accurate one is recent technology, as recent as I think probably 10 or 15 years ago. Electronic field vector mapping, typically used in roofing. Well, it now has roofing, deck applications as well as balcony applications. Making sure that it's a lot more accurate. Doesn't use 2 inches of headwater, barely uses hardly any water at all, which is nice for the very high roof decks that we have to, amenity decks that are maybe 10 or 15 stories up in the air in a downtown situation. But the interesting thing is, and there's some colleges in the Midwest that mandate this, the owners mandate this essentially, is after the installation of the waterproofing, it's tested, okay? And then after the overburden, which is where it's a green roof or what have you, they can test it as well, just to make sure there's no damage by the overburden trades or any other person who's decided to walk out onto the membrane. And that's pretty cool. Now, there's also some options that actually the owners will pay for, and they'll have that testing firm come back on a regular basis to make sure that perhaps once every 5 years or maybe every year, depends on the dynamic movement, so that they don't have a breach in the waterproofing. Pretty cool, huh? It's kind of preventative too, huh? Proactive, I think, is the other business word that they use. So there are these options. Are they expensive? Yes, they're more expensive than flood testing. Of course they are. You get what you pay for, obviously. Defects and repairs, there are splicing details and repair details available. They need to be in the submittal package so that, again, the communication piece, we have all this information up ahead of time. You take care of all these things right here, I think you're going to take care of most of those challenges, if not all. A couple of ones that are specific to balconies. But again, I don't want to limit the conversation to balconies, but these items here have been shown to be some additional challenges, additional things that we need to make sure that we're taking care of, and especially door sills. Access to balconies. Water can travel underneath the sills if there's not a step up, which typically there's not. Or they set it into a sealant and then there's water and then the water eventually compromises the sealant and it goes inside. Column penetrations, a lot of times those details are, the columns are and the railing is installed after the waterproofing, and sometimes they drill right through the waterproofing, causing a problem. But no, they need to have stanchions and stands so we can waterproof those, and then they can put on top of the stands or the stub ups, put the railing or the column support structures. This the edge metal, if you look at that picture above, that edge metal is called a T-bar. If you look at it from 90 degrees, and I'll show you a T-bar a little later. It's a two-piece detail, L metal with a T-bar, and the T-bar limits the concrete, but it also drains the waterproofing layer. So we have a drainage layer. We can drain that waterproofing layer very, very effectively. Keep it away from the building. I think that's a really good goal. And then consider, if you have a wood structure support, consider using preserved wood, in other words, treated wood. It will increase your cost, but you won't get these wood rots as bad. Actually, keep it from rotting too. So those are some design considerations that cover the challenges. So now we've got to figure out, okay, which membrane am I going to use? Okay, let's talk about, again, big funnel stuff again. What is a primary waterproofing? So what are the characteristics? Well, I call them the big 3 C's: continuous, complete, and constant. The 3 C's. If you talk about the complete part, you know, it's got to be continuous. It's got to be, your pen, crayon can't come up on the detail. It's got to be, we've got to connect everything. And there has to be waterproofing protecting the structure. Robust and durable, most of them are designed for the life of the building. It is the complete part that I want to focus on real quickly. These are the layers of a standard waterproofing system. There they are. Which one are you going to cut? It's called value engineering. Which one do you want to cut? Well, they all have a function. If you want to take the waterproofing, oh, well, hey, I got a value engineering. Let's use secondary waterproofing. No, let's use damp proofing. Let's use that. Well, if you do that, then you don't have that function of bridging cracks and preventing water. The most common one is the drainage layer. I don't have room for that drain board composite stuff you guys have, that dimple board. I ain't got no room for that. No idea what accent that is, but anyway, there it is. What's the drain do? It tells water where to go. It's the only thing that communicates with water. The other one blocks it like a dam. That's waterproof. So again, if you cut one of these layers out, guess what? You're gonna compromise the longevity of the system. So just wanted to kind of tell you that's the big part of the funnel. Let's narrow it down to decks and balconies. Some of the best practices for selecting it. Again, risk tolerance. I would submit to you it's 0. Service life, as long as we can do it. Now, there are certain applications where there is a way to maintain it, but I think the longest that the owner can get is what the owner wants. A membrane that handles certainly timing, as far as when can you pour concrete on top of it, when can I install the green roof application, when can I get to the mortar, when can I get to the, right? That's the timing piece. Exposure is, it's been sitting there for 30 days. Can that membrane handle that type of exposure? Some can, some can't. Track record, hey, has this thing been used before? I don't want to be the experiment. It should have a track record. The goal of anything as far as a membrane is to deliver the least risk for the lowest cost, and trying to manage that conflict, if you will. The easier it is, a membrane is to apply, I can assure you the more consistent it will be installed. Some membranes have limitations. Takes them a week to cure. Some take 3 days to cure. Some take an hour to cure. Some dry so fast that you can't, use them, especially over 95 degrees. There are temperature, moisture limitations as well. Temperature and moisture, but mainly moisture. Some products have to have a completely dry substrate. Some, it doesn't matter. What are we doing here? Is this new construction or rehab? In rehab, compatibility and use, maybe we've changed the use of it. Maybe we had a topping slab in the new construction piece and we've jackhammered that up, reestablished the waterproofing layer, and we're going to put a green roof on top of it. So change in use. And then they're also return to service. I think all owners want to, especially if the podium deck's in the front entrance, guess what they want done first? That front entrance, and return to service as quick as possible. Got to comply with the codes? Of course we have to comply with the codes. Are there some membranes that don't comply with codes? I'm sure there are. I don't know of any, but I'm sure that secondary waterproofing doesn't adhere to the code. Primary and secondary. So is there a tertiary waterproofing? Well, we call that water stops, right? So let's just talk about primary and secondary. So what does a primary do? Again, it prevents bridges, but it waterproofs the structure. That's its function. It doesn't do anything much else than that, whether the structure is below grade or above grade. Secondary waterproofing is part of a system. It protects the underlying part of the system. That's its function, to protect a product, not a structure, but a product. Whether that product's a mortar, an adhesive, it can actually do some overlying stuff and protect the finished material as well. At the end of the day, if you use secondary waterproofing on a deck or a balcony, more than likely you're going to get sued because it's not designed for it. It's that square peg and a round hole issue. Okay, so the other one I don't recommend, or we don't recommend you using, is dampproofing. And again, it's a function thing. What does dampproofing do? It resists. What does waterproofing do? It prevents. Anybody ever tell you buy a watch, hey, it's water resistant, and then you go and dive 10 meters down into the ocean, or maybe you dive into the pool and you're wearing your watch, it's because it's water resistant. You come back up and it's full of water. That's using dampproofing, because you dove into the water and it works just right there at the surface, right? But when you give pressure to it, hydrostatic pressure exists at the bottom of a pool, or if you're in the ocean, 10 meters down, 30 feet down, whatever the measurement that you want to use, you go down 1 foot, you're going to put hydrostatic pressure on that watch. So don't use dampproofing. It's only resistant. It doesn't prevent water under pressure. Well, John, it's a deck. I mean, come on, it's above grade, John. Come on, what's the big deal? Well, what the big deal is, if you're in a planter and you have water accumulating 1 inch, you've actually induced hydrostatic pressure. Why is that 1 inch there? Well, the green stuff in the planter needs that water. And so we've induced a hydrostatic pressure on the membrane. So use waterproofing. Another reason why dampproofing doesn't bridge cracks. Well, why is that important, John? Good question. Planters are made, and most decks are made, or all decks are made with concrete cracks. Dampproofing doesn't bridge cracks. There's not enough of it there. So don't use secondary waterproofing, don't use dampproofing, and here's the reasons why. Make sense? Cool. So let's talk about the buckets of primary waterproofing that are used in decks and balconies. They'll have two buckets: preview, sheet applied, and fluid applied. On the sheet applied, it's either going to be a peel and stick membrane, that's the high density asphaltics and non-asphaltics, or roofing membranes. Roofing membranes are PPO, FPO, PVC, and EPDM. Those are roofing membranes, because after all, a deck is you guessed it, a roof. It's over occupied space, that would be a roof. Always recommend that all the studies, all the consultants, all the literature recommends always use an adhered system, never use a loose laid system. especially with these roofing membranes. You always want this thing stuck to the structure. A couple of advantages are, the biggest one, hydrostatic head resistance, is the highest. These guys are the highest head resistance. And the other is the consistent thickness. The factory's making this stuff, and the factory does a very, very good job making it at a certain thickness. The other factory, quote unquote, very loose, big turn is used on fluid applied. The factory's on the job site. And who's making it? Well, the contractor is. So if you believe in consistent thickness, sheet apply is the way to go. If you want ease of application and no seams, because all sheet applied has seams, then fluid applied. There are two types of fluid applied used in deck and also balcony waterproofing, cold fluid applied and hot fluid applied. Cold fluid applied has two parts. The moisture urethanes, that's the biggest used, that's the biggest one. And the moisture reactive polyethers are the other one part membranes. Two-part membranes are basically polyurethanes, and then we're going to modify polyurethanes with a methacrylate, and we're going to modify polyurethanes with a urea. The methacrylates and the ureas give you spray application. They also give you a quick curing, but they are very moisture intolerant. The two-part aliphatic polyurethanes are very, they might be the best tool in the toolbox because but the problem is they're two parts. And so sometimes installers don't know that A and B go together. Sometimes it happens. Hot rubber is the other one. That's one of the older ones. Hot rubber and peel and stick are the old guys, the old men of deck and balcony waterproofing. I would just tell you that it takes quite a bit of thickness for the hot rubber, 215 mils versus half that for the cold fluid applied in order to get the same testing characteristics or the same functioning characteristics. That's fine. Hot rubber is very complicated because it requires a kettle. The kettle is something that to heat it up. If you ever see me, you can always ask me, can you show me your hot applied rubber scar? Because I have them on my hands from splashing hot rubber because it melted my skin. And the only good thing about it, it's cured right away. I mean, it snap cures. Once it cools down, it's ready to go. So that's its biggest advantage. Never use, again, reiterating, never used cold fluid applied rubberized asphalt. They go backwards. They revert. So there's your best practices on membrane selection. We've got the design consideration and covering up our challenges, right? So what about MAPEIs? These are all the different types of waterproofing. You see we have a blue thing and then pretty much everything except for hot and crystalline waterproofing. They'll be coming to a theater nearby you. A little bit deep dive into the decks and waterproofing, decks and balcony waterproofing. So here's your sheet applied waterproofing is Mapedrain, cold rubber 1, Planet Seal, CR1, and then CR2. That's the lineup, including the drain board, all from MAPEI. Standard, same as it ever was, 1960s Mapedrain, basically. Been made since then. The first thing in the name of MAPEI is adhesives. Contact adhesives, they say that we got, they say, not MAPEI, customers say we get the best one in the industry. Well, it's a good thing it's part of our name. Very, very part of our name. First part, very good at that. The machines make these, so it's very consistent thickness. 60 mils is the thickness. Cold rubber 1, Planet Seal cold rubber 1, moisture reactive polyether. It uses water and gives it back up. It doesn't break it apart. And water won't break it apart because it's designed for ponding water situations. Another ponding water situation product is Planet Seal CR2. It's a 2-component polyurethane. It can be used as a standalone membrane, but also detailing membrane for Mapedrain, the aforementioned Mapedrain, as well as a blind site application in our ALNA product. It's compatible with, the cool thing about CR2 is it's compatible with everything. I mean, you name a waterproofing system and this thing sticks to it, which is kind of cool. Even greater is when you have a hot rubber situation that's leaking, you can use this membrane to fix it rather than toting the kettle all the way up to the top of the deck. Mapedrain, we use, there's no really application that you can dream up that we don't have a drain for. The ones that are used on the decks is the 30, 35. That's for poured in place or mortar applications on top of cementitious products being put on top of it. Green products, we use the Mapedrain 40. And then if we decide that we want to have a driveway to access our building, and the fire code says we have to have a fire truck that, or a system designed for fire truck, the Mapedrain 50 is that ultra high strength drain board. We use polypropylene. A lot of folks don't use polypropylene. It has the highest chemical resistance of all the types of drains. And so it'll take the water, the contaminated, the high pH waters, the urine, because if you have a green space, maybe it's a pet area, they do their business. It's tolerant to that, as well as other chemicals as far as fuel and hydraulic fluids as well. It's these three on concrete and these three on plywood. They're interchangeable. If you want higher warranties, then the Planet Seal CR1 has 20-year type warranties. The Mapedrain and the Planet Seal CR1 typically 10 years, 10 to 15 years, somewhere around in there. There's also specialty applications, but we're always going to talk to you about it beforehand. Understanding that MAPEI is a soup to nuts manufacturer. What does that mean? We cook real well? No. We start a meal, usually you start a meal off with some soup and you end it with a cocktail and nuts, right? So beginning to the end. So we make all of these products and a whole lot more. So when you buy or specify MAPEI from a product perspective, this is what else you get. You get a person piece, a people part. And this is what we do, product literature, specs, CAD details, warranties. General support is phone and field support, including product training, as well as warranty support. Product training, we do the contractors, architects, consultants, and distributors. We'll be happy to come by and take a look and put some products down if you want to. Pre-construction, we do document review with a waterproofing system recommendations, as well as design. And then we also do project specific CAD details for free. Excuse me. Job site support is pre-con, startups, visits, as well as installation and substrate reviews, inspections. A couple of final thoughts real quick. I got a minute or two left here. Anatomy of a leak. Water's inside my apartment. What am I doing? What's going on? Right? So we'll put water on that little picture there on the left. You put on the right of that picture. We'll put water there and see where the water goes. So we put water and it goes to the drain. That's great, fine and dandy, but it's daylights in two areas of concern: a crack in the topping slab, which that's fine. We can handle that. If it's enough, it'll slope to the drain, right? But what it is that little dot on the extreme left, right by the door frame. That's the problem. And so that's why the water is going inside the, see, so this is that anatomy of a sill leak. That other picture that I showed you, that the owners were contacted by the tenant on the other side of the window wall, this is part of that investigation. So from above on the left, that's if we had a drone and we're looking down on this plaza, there's your ponded, in the red is the ponded water area. Well, that doesn't look very bad. I mean, look, it's high, it's deep there, it's no problem, right? Well, the blue is higher than the light blue. So it's curved properly on the left side, but as you move towards the red thing, you see the gap between the darker blue with that lighter blue. Well, that's where the water goes. It goes path of least resistance. So you have to have this curved up away from the building, away from the building. Drip edge T-bars, looks like a T, turn it on its axis. That's what a T-bar is. What it does is concrete's on top of the top part of the T, and the bottom part of the T is where the water drains out over onto the fascia away from the building. Drains the waterproofing layer. Paver and pedestal advantage. This is so cool. I mean, if you don't like to see drains in the middle of your pretty overburden, use paver and pedestals. You can hide the drains. See that? On the left, exposed drain. On the right, hidden. Kind of cool. And it's actually really easy to repair. Just pull the pavers up, more than one person probably, because they're pretty heavy. And repair it if you need to, or clean out that drain. Very easy to do. Ladies and gentlemen, that just about wraps it up. My hope is that this was informational and might start a conversation about a balcony and deck waterproofing. Thank you very much.
Thank you, John. And actually, I think we are going to have a bit of a conversation. There's a question or two here. And the first one is about slope. So your final thoughts were apropos. Does the ADA impact slope, ADA requirements?
ADA requirements are slip and fall, and yes, they do. But again, we're talking about structural concrete. And if we have any type of slope on the finish material, the overburden, then yes, I mean, if we don't account or make it flatter at the top on the topping, then yes, ADA would also come into it, but not with primary waterproofing. Has nothing to do with it. That would have to do with paver pedestal, or if we had a topping slab and we wanted to put some sort of concrete stain and sealer on top of that, then the ADA would come in at that point in time. On the top.
On the top. All right. Did that answer the question, Connie? Give you a second to type in here. Okay, cool. Well, it looks like we are hitting our time limit, and if there are any other questions, please do send them to us at MAPEI Digital at mapei.com, and we'll be sure to forward them on to John. And John, thank you again. That was an awesome presentation, very informative. And we thank everybody for their time today. We know that it's very busy, and we do appreciate you spending some time with us. And John, we'll look forward to your next presentation with us. And we'll look forward to everybody joining us again at the next one. Have a good afternoon, everyone. Thank you. Bye.
Cheers.
Bye-bye.